So finally, all right, we talked about we talked about the periodic table, we talked about elements, those cute little atoms. Cute little atoms get together to make compounds. And actually we talked about Lewis structures with molecules, and we talked about making ionic compounds. So the reason to me that the atoms get together the way they do, actually there's a reason for that. Okay? So talking about chemical reactions. A chemical reaction is one that basically occurs because, and I'll go ahead and kind of start this convention. You guys are probably already familiar about chemical equations. Okay, chemical equations represent chemical reactions. We put reactants, okay, on this side, and you read chemical equations from left to right describing the reaction just like you read a sentence from left to right. Okay. Okay, so this is my chemical equation. One of the things, and you mentioned like the report that's due in one of your classes, I do not like paragraphs, I do not like words, you know, but chemical equations are like, dude, that is so cool. Okay, so of course reactants are what you start with, and products are what you end with. And the reason you would end with something different than what you started with is actually the products, their arrangement of atoms is more favored. Okay? What this says is actually there's a conservation going on. Basically, and there's a lot of laws of conservation. This blue is talking about conservation. It basically says that all of the atoms that you start with are atoms that you end with. They're conserved. And I kind of think of that reaction arrow between what you start with and what you end with, your reactants products. That reaction arrow is kind of like a magic black hat. So you throw your atoms in there. What you start with needs to be representing what you end with. Then this is actually, this talks about nuclei. No nuclei are hurt. What that just means is that you're not going to end, remember the nuclei is what harbors the protons, and the protons are what makes an element what it is. What an atom is going to be. Okay, so how do you know a chemical reaction has occurred? And we've talked about this before a little bit, but I have some slides again to kind of talk about it. If there's a color change, okay, a lot. You know, we didn't see this kind of stepwise, but basically we're taking two clear reactants and getting something pink. A chemical reaction occurred? Quite possibly. Okay. The next one. We're taking two clear reactants and getting something that's kind of fuzzy. We actually call that a precipitate. We've been talking about that in our Chem 2 class. This thing down here is actually, I'm going to put an S here. What's the S stand for? Solid, yes. Okay. So, who is clicking their pen? It's just like, dude, this is a really small class, and I don't want to draw anybody's attention to it, but it's irritating. So is like rifling through your crap while I'm trying to lecture. That's irritating. Okay, if you were doing it, you would think it's irritating too. So here we have something that's clear, okay, actually, and something happens. We get bubbling stuff. When you guys did your observations lab, in some case it bubbled, it gave a gas. Gas is something new, okay? If something gives off heat, it may or may not be a chemical reaction behind the scenes giving off that heat. If something gives off light, okay, it may or may not be a chemical reaction going on. So a chemical reaction by definition, and I think it was on the previous slide, a chemical reaction means you have to have something new. If you look on the product side, or if you look after your process and you have the same stuff, no chemical reaction has occurred. Okay? So here's a warning though. There are times when you observe, I don't know about color change, but there are times when you observe heat released. There are times when you see light emitted. There are times when you see something dissolve when no new substances have been formed. And then no chemical reaction has occurred. And actually in Unit 1, clear back forever ago, we did do I give you an example of something you could just observe, and you had to tell me, was that a chemical reaction or not? would new substances be formed. So let's take a look at these. These are going to be due on Monday. And they look like this. Here you guys are. Okay, remember the blue actually have answers in the back of the book, but no calculators required for this, right? So what is a chemical reaction? I think you guys can probably write that down. List some examples. Feel free to use this chapter, this textbook. Just write down some chemical reactions, your favorite chemical reaction. Remember, chemical reaction is just something, it's written with a reaction arrow. We'll be talking more about equations on Monday. But it's just showing what you start with and what you end with is something different. And number 2 is if you could observe the atoms and the molecules on a small scale, okay, what would you look for? If you could see, I guess I should say, if you could see the chemical equation representing that reaction, what would you look for? And I guess to me the answer is something different here on the product side. I don't mean to do your homework for you, but that's what I would do. Number 3, what are the main indications that a chemical reaction has occurred? You need to observe something new has been formed. Put another way, though, it's quite possible that you take 2 clear liquids, you put them together, you get a third clear liquid. And it's possible that a chemical reaction has occurred, too. Okay, so that's kind of what you're up against. For 25, it looks like this. Which observation is consistent with a chemical reaction to have occurred? Again, this is very kind of similar to what you guys did clear back in Unit 1 in here. Okay. For number 1, it says copper deposits on a piece of aluminum foil when the foil is placed in a blue copper nitrate solution. The blue color of the solution fades. Okay. So to me, the blue going away means that you are consuming something. You have something new being formed, something's depleting. So I would say chemical reaction. So kind of take a look at those. All right. So we're going to go on with just a few more slides. We aren't going to get to the famous balancing those equations. That will be on Monday. But I just want to introduce a chemical equation. An equation, like I said, is a kind of a shorthand way of describing a reaction. So you read equations, usually from left to right, like you read a sentence from left to right. I wondered about those cultures like Chinese that don't they go from right back to left, I think, when they write and when they read, or kind of up and down, I don't know.
It's like up and down.
Okay, but there are some cultures that go that way. And I wondered if in their physical science, when they talk about chemical equations, do they struggle with this? Okay, so reactants are what you start with, products are what you end with. Already I can tell you on your Unit 4 exam, I'm going to be kind of asking you general questions about equations. Okay, you start with reactants, you end with products. Okay. So there actually are 2 types of equations, chemical equations representing chemical reactions. There's the unbalanced equation, which your textbook uses the word skeletal equation, unbalanced. And some of you are already kind of familiar with this, taking an equation and balancing it. Okay? We're going to talk, like I said, we're going to talk more about that on Monday. But what unbalanced does is basically kind of, if I'm holding up my hands like this, we don't have the same number of atoms on either side of the reaction arrow. Between my hands are a reaction arrow. That's unbalanced. Balanced, it's a kind of a fun process. You kind of actually put these things, these big numbers, to the left of each species to make sure that you do have the same number of atoms on either side of the reaction arrow. That's balanced. So the thing about unbalanced chemical equations, even though they're not balanced, they still give you some very good information. One of the things they do is unbalanced equations will give you what I'm going to call in a minute qualitative information, not quantitative. So qualitative, one thing is basically what's reacting, what's being formed. Okay, they give you that. Sometimes, and like I said, equations are so concise. I love chemical equations. Sometimes there'll be a little letter next to it, and I think this is one of your homework questions. You guys told me an S stands for solid, a G would stand for gas, an L would stand for liquid, exactly. Sometimes that'll be right next to the species. The other thing you can have with an unbalanced chemical equation, falling under the category of qualitative versus quantitative information, is concisely you can say to the reader of your equation, are there any specific reaction conditions that you need in place in order to, what we say, proceed from reactants to products? And oftentimes those are put over the reaction arrow. They're just so concise. These are over. RxN is my version of reaction over reaction arrow. Any special reaction conditions. Who needs a paragraph when you can just write an equation, right? Okay. So this is what you were telling me, that the S next to something means that that something is a solid. The L means something is a liquid. The G something means something is a gas. Now let me take just a minute and tell you what the AQ means. Okay. Do you get the word kind of water out of aqueous? Okay. So basically you have water is the solvent, and you have something dissolved in water. I almost said ionic compounds, but it doesn't have to be an ionic compound dissolved in water. So if we do this sort of thing, NaCl, solid, dissolved in water, and I don't know if this would be over your reaction arrow, but I guess it could be dissolved in H2O. Why write water when you can write the equation for water? Okay. And then on the product side, we would write Na plus, AQ plus or plus 1. How do we know that? Because it's a 1A element. Okay. If you dissolve salt in water, this is what you're going to get. And then it's going to produce Cl minus or minus 1. Also, it's going to be AQ. Now, if I had like a whole, you know how you can buy salt at the store, and it's like this container. If I had the whole container of salt and just a cup of water, is it possible that I pour in the salt and not all of it's going to dissolve? Yes. But if what does dissolve looks like this. All right. So over the reaction arrow, you might see one or a couple of these. If you need heat to make it go, that's good information to concisely say. If you need not just heat, but a specific temperature, a lot of your biological processes would definitely kind of get into the nitty-gritty of things you need. If you need an enzyme to go from reactants to products, that could be over the reaction arrow. Enzyme is a type of catalyst, actually. If you need dark conditions, etc., over the reaction arrow. So this idea of an unbalanced chemical equation, the three things I said it could tell you are the reactants and products. I said it could tell you the physical phases, and I said it could tell you if you need anything special to proceed from reactants to products, any special reaction conditions. Now, quantitative information, we're going to talk about that more on Monday, and that can come only from a balanced equation. Versus the skeletal or the unbalanced equation. So let's take a look at these. These aren't too bad either. Like, I can't believe she's assigning stuff to be done. Well, let's look at them. Like I said, they are not too bad.
How long do you think we'll be in this, like, between our tests and now, like? I know I remember you saying this was like a shorter, like it's not as long.
I'll try to this weekend kind of look at the schedules to kind of map in a unit
have
for
like
exam.
a month exactly from the final.
Yeah. No.
For the final.
Yeah, the final's coming up, right?
Yeah, it's only a month away,
right.
so that's why I figured we're only going to be on this
Yeah.
for probably a couple of weeks.
A lot of times what I'm going to do, just so you know, when I give you a tentative date on Monday, is I'm going to look when the final is and basically kind of backtrack a couple of lecture days for Unit 5, and kind of that Thursday-ish is going to be where it is. So
Okay.
I don't want to mislead you and tell you a date now, but I will look ahead, and I will confirm that the 11th is your final exam day for here. Best I can do, I know. Welcome to college, right? So these will also be due on Monday for a separate assignment. So what is a chemical equation? Describes a chemical reaction, right? Provide an example. So what I would do is write a chemical equation, and then underneath it I would say, Reactants, dot, dot, what the reactants are. Products, dot, dot, what the products are for the chemical reaction you chose to write down. You know, kind of thinking outside the box. The next one's pretty straightforward, you know, A through D. What do they represent if you see an S, an L, a G, an AQ, okay? So that's all I have today, right? So tomorrow, or on Monday, we'll definitely finish up